Welcome back, guys. Today we're here with another video, and this time we'll be going over Calc AB, and we'll be going over one of the FRQs, and this is question number 6 for 2025. And this might seem a random video, but I've been wanting to do this video for like a long time now because as a nerd, I was doing a Calc AB FRQ. I was like, oh, this seems interesting. And I was never good at implicit differentiation at all. Like I sucked at it. But then I did this problem and I was like, wait, this is really straightforward. And I'm kind of like understanding it more now, but still I just wanted to show you how to do these problems. So look, this is a screenshot. So let's get started. So with the first question, with the implicit differentiation, it says that show that dy dx is equal to negative x over 2 times 3y squared minus 2y minus 1. So we're given the function here, which is y to the 3 minus y squared minus y plus 1/4 x squared is equal to 0. Now, when you implicitly implicitly differentiate something of this, you have to realize that we're doing it with respect to dy dx. And so what this means is that whenever you get a do differentiation with anything of the y variable, when you do it, you have to add dy dx after it. And the reason why that negative y is just dy dx is because y or x, if you derive it, it will just be 1. And so from here, in order to solve for what dy dx is, or rather to show what dy dx is, all you have to do is just take the dy dx out, factor it out. And then you can just move this 1/2 x to the other side. And then from there, you can just divide this whole thing because you're trying to isolate dy dx. And then from there, you're left with dy dx is equal to negative x over 2 multiplied 3y squared minus 2y minus 1. And so that'll be your answer for question number A. I'm sorry for the zooming in. So question B. There's a point P on the curve G near 2, negative 1 with x coordinate 1.6. Use the line tangent to the curve at 2, negative 1 to approximate the y coordinate of point P. So we're given point curve G, which is near 2, negative 1 with the x coordinate of 1.6. And we're trying to find the line tangent at the curve of 2, negative 1. So we know that point P is near, oh my god, is near 2, negative 1. We know that the x is equal to 1.6. And so what other information did they give us? Now they're just saying use a line tangent to the curve at 2, negative 1 to approximate the y coordinate of point P. So this is where you have to read and actually understand what the problem is trying to tell you. So from here, we see that curve G is defined by the equation. And we're seeing how they're trying to use the line tangent in order to find the y coordinate of point P. And so if the x coordinate of point P is 1.6, then that means we have to find the slope, which we can do with the differential equation we found here. And so from here, we can actually just put your x and y coordinates Put this little line for, forgot what it was called, but it's an error. I remember if you don't put this line here or you don't put your coordinates, you don't get points for it. So always remember to put that little line. From here, you can just substitute every single letter. Three plus two is five, minus one is four. And so then the slope is equal to negative 1/4. So from there, you can set up your point slope formula. And so from here, we have y minus negative 1 is equal to negative 1/4 x minus 2. From here, you can really just say y plus 1 because anything negative times a negative is always a positive. Then from here, you can also just factor as well. I mean, distribute, my fault. Or if you're really fancy, you can immediately just put, forget this. You could always just put negative 0.4 here. Now, but what does this mean though exactly? This just means that y plus 1 is equal to negative 1/4, and if you want to turn that into a fraction, you can just do so by turning it to negative 4/10. And from here, you can see that y plus 1 is equal to negative times a negative, which is just a positive, and then you can cancel out the 4's. So it's just equal to positive 1/10. And to just so for y, you can just subtract the 1 from both sides. And you're left with y is equal to negative 9/10. Can I zoom out? What's going on? Now, for question C, for x is greater than 0 and y is greater than 0, there's a point S on the curve G at which the line tangent to the curve at that point is vertical. Find the y coordinate of point S. Show the work that leads to your answer. I don't know why is this malfunctioning on me? Change the color. So, what these fancy symbols just mean is that x and y are both going to be positive. And since we're trying to find the line that is undefined, that means we're trying to find where dy dx is equal to undefined. Now we have to go back to our differential equation, which was just negative x over 2 3y squared minus 2y minus 1. Now, since we're trying to find where it's undefined, this means that we're trying to find the vertical asymptote, basically. Because remember, in the graph, a vertical asymptote is always going to be vertical, while a horizontal asymptote is always going to be horizontal, hence the names. And so from here, we can safely assume that whenever a rational function, which this is a rational function. I think so. Don't quote me on that. To find the vertical asymptotes, we can just factor out the 3y squared minus 2y minus 1. And so from here, if you're okay with cross method or anything, that's totally fine. But this is how you factor it, because you get the negative y, then you get the 3y. My mistake. It's the other way around. Don't pay attention to that. Because you get the y here, then you get the negative 3y. When you combine them, you get negative 2y, and then 1 times negative 1 is just negative 1. So from here, we can say that these are the factors that multiply each other and give us the not the remainder, but what was it called? It was called something, I don't remember. But it ends up to being 3y squared minus 2y minus 1. And so from here, we can just see the solutions, just make them equal to 0. Then we see negative 1/3 is equal to y. Then y is equal to 1. Now, the important thing to remember is that the question asks us that for anything that is positive for x and that is positive for y. And so you can immediately just eliminate negative 1/3 because it's not positive. The question explicitly said that it has to be anything that is over 0. So y has to be greater than 0. And so the only solution that's left for us is y equals 1. Scrolling. A particle moves along the curve h defined by the equation 2xy plus natural log of y is equal to a. At the instant when the particle is at the point 4,1, dx dt is equal to 3. Find dy dt at that instant. Show the work that leads to your answer. Now I'm sorry if I'm doing a lot of scrolling. That is the equation that they gave us. So we're trying to find dy dt. And they also gave us that dx dt is equal to 3 and that the point is 4:1. Now, the most important thing to know about this equation, I guess, is that in order to find dy dt, you have to realize what dy dx really means. Because basically dy dx is just dy dt over dx dt. Because since there's an x and y variable to find the slope, you have to do this. Because as you can see from here, when you keep change flip, you cancel out the dt's and you just get dy dx. So our equation is 2xy plus natural log of y is equal to 8. So from here, you can just implicitly differentiate again. Make sure that's right. Yep. So from here, you have to do product rule because you have a 2xy. So for product rule, it's d1, it's 1d2 plus 2d1. So if you don't understand what that means, it's just the first function, then the derivative of the second function, plus the second function with the derivative of the first function. So from 2xy, you can say 2xy times dy dx plus y 2x. I'm sorry, just 2. Just 2. And then plus 1 over y dy dx is equal to 0. Then from here, you can just put everything to the left side. So you can put this negative, you can subtract this 2y from both sides, and then factor out the dy dx. So you should just get 2x plus 1 over y is equal to negative 2y. Then from here, you can just isolate the dy dx. And since you're given the points 4 to 1, you can immediately just put it into the equation, or to the differentiated equation. Which is equal to negative 2 over 9, which is your dy dx. Now, we're not done after all that, which is insane, because I almost got a headache right now. But dy dx is equal to negative 2 over 9. But we're also given that dx dt is equal to 3. Now, since we know that dy dx is equal to negative 2 over 9 and dx dt is equal to 3, we have the amount of puzzle pieces that we need in order to solve for dy dt. And again, we can write this out. So dy dx is just equal to negative 2 over 9. We're still trying to find for dy dt. And then dx dt is just equal to 3. So from here, in order to isolate for dy dt, you can just multiply by 3 to both sides. This will give you negative 6 over 9. And if you simplify it, should give you negative 2 over 3 is equal to dy dt. And that is the fourth question done. And obviously, the sixth question on AB is always very, very difficult for implicit differentiation. I believe it's always implicit differentiation or something like that along the curve. So definitely study up on your implicit differentiation, your point slope form, and what it means for undefined. I think it's really important because if you're able to get, a lot of points on the FRQ for number 6, you're really able to do great on the rest of the FRQs and on the whole test as well. So that has been a run through of the Calculus AB FRQ number 6 question from 2025. I hope you enjoyed it. And obviously, since this is calculus and no one is perfect, if I made a mistake, please let me know down in the comments. Yeah, you see all this work? They don't give you a lot of pages for this one, I promise you that. But I hope you liked it, guys. Thank you for watching, and goodbye.